There, I think we're good now. I think we're good now. Hey, everybody. Hey, everybody. I think we got this going now good. So, good Monday, Tuesday morning. I guess it's Monday because it's still gray and cloudy outside. Get a few minutes to get everybody signed in here, and then we'll get started. All right. All right. So, let's get this going here. Let's get this going here. For anybody who for anybody who does get signed in here, just kind of give me a hello so you guys can so that I know that I'm not talking to a gray screen or anything of that sort. I mean, that would actually be a very helpful thing. I had to get my little fail safe on my own here. So, but try to keep monitoring on the chat. We'll kind of get going here. So this little half hour, this little 25 minutes, half hour is going to talk about, going to kind of pertain a little bit to sixth grade, kind of what we were trying to talk about yesterday, but also kind of going through the Aloha packet. So if you have the Aloha packet, and bring this up, the Aloha packet, oh, close. Oh my goodness. It's early for me too. So the Aloha packet, it should look something like this. So those of you who have this, by all means bring this up. I'll go through and help out and guide with some of the information that's on here so you guys can get working through that. I know there's a lot of it was what on this specific packet there was like 12 pages of some sort. So let's see here. What I do want to kind of focus real quick with is that yesterday. So yesterday during the gray screen of the live stream that we did, I was talking about evaluating expressions when it comes to sixth grade. So like with an expression, if you had something along the lines of 5x, and it says evaluate the expression if x equal 2. So like if x equal 2, when it comes to evaluating, all it is about substitution. Substitution. Yay. Yay. You can sense my sarcasm, right? So, it's brought down here. So, with x equaling 2, all we're doing on this is we're just substituting it into the expression. So if x equals 2, we're going to substitute 2 in for that. What's 5 times 2? 5 times 2 is 10. So when someone asks you to evaluate the expression 5x when x equals 2, you know that your answer is 10. Now I know that in our, a lot of times in our classes when we were going through this, I think the struggle came when, let's get rid of this on the screen. The struggle came when it was something along the lines of, let's see if I can get a little, bit of a, it was something along the lines of AB squared over 2 if A equaled 4 and B equaled, let's go 3. And I think the issue was when it came to putting multiple steps into everything. And to be totally honest, I mean, evaluating is just a substitution and following order of operations. Always remember, please excuse my dear Aunt Sally. PEMDAS. Yes, right, PEMDAS. There we go. So if A equals 4 and B equals 3, let's substitute these values into that expression, A equals 4, you're going to now go 4 times, and B squared, if B equals 3, it's 3 squared over 2. From there, you do what first? You do your parentheses, your one with the exponent right there. So let's move to our right. So 4 times what's 3 squared, or 3 times 3. 3 times 3 is 9. 4 times 9 over 2, you do your multiplication in the numerator. 4 times 9, 9, 18, 27, 36 over 2. And then 36 divided by 2 is, in my head here, should be 18. Yeah, 18. Okay? Just remember, evaluating expressions, it's substitution. Full-fledged just substitution. So, but that was kind of the big thing about that yesterday. Even with the re-upload that I did, with everything there. So, with that being said, let's go into the actual packet. So I'm going to make my do not have the Aloha packet on you. So let me reappear here. If you do not have the Aloha packet for some reason, I will cover 2 other packets in the subsequent streams this morning. So I'm going to try to cut this stream into 3 separate pieces, just so that it's not one long 1 hour and a half-ish type stream. But I'm talking the Aloha yard sale packet for the 3rd one, and I'll label them appropriately for each stream there. So let's get going with this. Let's see. Get this off the screen. So am I going to do every single part of this? No. Am I going to? It was lines, angles, shapes. It was like recipes and math at the mall or something like that. You know, like we're kind of trying to split those apart a little bit too. So let's see here. So let's go right to the front page. Front page. We see this thing called vacation expenses. So let me make sure I'm off the screen here. Vacation expenses. Use the information on the list below to answer the questions. And we're just talking about word problems. Everybody's favorite word problems on this. You're given this nice little chart. This nice little chart right here. Wow. Okay. This nice little chart. And the first question you have is, how much did Mrs. Boomer, yes, Miss Boomer, so Miss Boomer spend on her Hawaiian vacation? I guess down here is Miss Boomer. She's lounging on the beach, not quarantined or anything of that sort, not hoarding toilet paper or trying to go get bottled water or eggs or anything of that sort. So let's take a look. How much did Miss Boomer spend on her Hawaiian vacation? Well, this is rather easy, just for the fact that off of here. So, how much does she spend? Well, she's spending on airfare, hotel, car rental, souvenirs, scuba diving, meals, and entrance fees. Ladies and gentlemen, all this is just one big addition problem. That's all this is one big addition problem. These are all expenses that she is incurring on this. Incurring meaning she's she's facing in this instance. So when you're looking at this, all you're doing is you are adding everything up. And I'm just going to add this up for sake of time here. 50 plus 220 plus 40, 75. Gives her a grand total for her little Hawaiian vacation is $1,437. $1,437. So hopefully you have something along those lines for your answer for that number 1. But then as you scroll down, just remember $1,437 for that. It's just one big addition problem there. But the next part is a couple of different parts here. So keep that number 1,437. I'm going to erase the bids like Price is Right here. 1,437 was our total. 1,437, and then the question number 2 becomes, well, Miss Boomer saved $125, so $125 a month for a year for her vacation. Did she have enough money for her expenses? So did she have enough money for her expenses? Her expenses, the amount that it cost her was $1,437. The expenses, everything that she incurred. These are not things that are given to her. She has to pay for this stuff. So the problem is asking you, did she have enough money if she saved $125? So if she saved $125 a month, does she have enough to cover the $1,437 that it's going to cost her? So plain and simple, 125. And you look here and you say, well, it's a month over the course of a year. Well, how many months are in a year? How many months are in a year? There's 12. So you're going to take that 125 per month and multiply by 12. Now, I will do the long division part of this, or long division, what am I talking about? The multiplication of this, 0, carry the 1, 2 times 2 is 4, plus 1 is 5, 2 times 1 is 2, and then you bring down your 125, because it's all multiplied by 1. When you add everything up, you will see that if she saves $125, if she saves $125 a month, $1,437, the answer is yes. So the question is did she have enough money for her expenses? It should be a big fat yes. She does, because $1,500 is more than 1437. 1437. For those of you following along, give you a chance to write that there. So give you a chance to write that, and we'll move on. We'll go to another one here. I know this is morning on a Tuesday. With, again, still gray skies outside and all that kind of good stuff. I just hope everybody's doing good. In the now stay-at-home order by our governor, and many people around us too. It's crazy times, crazy times we live in with this. Stay safe, guys. It's crazy things going on. But so let's now, on that same packet, I'm going to erase my screen here. So hopefully you had those two filled in right there. You're welcome. So let's scroll down. Let's scroll down and let's go to everybody's favorite. We're going to be turning percents into fractions, fractions into decimals, decimals into percents into decimals, percents from decimals, fractions and decimals. All those nice little conversion techniques right there. So, am I going to go through every single one of these? No. So let's get a couple of these going so you kind of get the gist of what we're doing here. And I hope, especially with all the practice you guys have had, that you guys should at least have some kind of an idea of what we're doing with this. So let's look here. Let's look. So let's take some of the easy ones here. Why it does that? Go around. So we look here. Look at that. What is the decimal form of 40%? So if we're going to change 40%, so 40% to a decimal, ladies and gentlemen, you remember all that you're doing on this is you're taking this decimal. Let me change the color here. You're going to take your decimal and you're going to move it 2 places to the left, which will give you, as a decimal, 0.40. Oh my goodness. So to change a percent to a decimal, all you're doing is just moving the decimal 2 to the left, So 2 to the left. And let me see if I can try to write some of these in here. So what's the decimal form of 40%? Should be 0.4D. So 0.40, I might have to go a little, I'm writing on my screen for those of you who are trying to figure out how is this crazy dude writing things on my screen here. So let's see. So you see for the decimal form of 40% is 0.40. So let's go to this one. What's the decimal form of 43%? Well, now you know if you move it 2 to the left, if you move the decimal 2 to the left, it's going to give you 0.43. Oh my, 0.43. That's not good. 0.43. You guys get the gist here. 0.43. The decimal form of 80% should be 0.80. 0.80. So 0.80 on that. And as you see with the way that we are doing this, the question's saying, well, what's the nickname for the island of Hawaii? So these nice little packets where they do these puns and these riddles and all this kind of good stuff. It has you fill out a nice little thing at the bottom. Let's scroll down a little bit just to kind of do this. If the decimal form of 0.4, so 0.40 would have the letter D. Let's see here. So I don't have a bunch of writing on this. Let's try to zoom it out slightly here. I'm going to erase my screen. So know this. I'll make it this way so I don't have to fiddle with this and take too much time. Just remember percent. So percent to a decimal. Change color. So if I go percent to a decimal, percent to a decimal. So if I had 43%, so if I had 43% changed to a decimal, all you're doing is you're moving that fictitious, well, not really fictitious, because technically what you're seeing here is 43.0%. When you change it to an actual full-fledged decimal, you're moving this decimal here 1 and 2 to the left. So it's 2 to the left. 2 to the left will make your decimal be 0.43. So that will cover, so that covers changing from a percent to a decimal. Give you guys time to at least have that written down there. Then the next part here, clear my screen. Let's go, trying to see here, decimal. So decimal to a percent. Well, yeah, this one should actually be not too bad. So if we go decimal to a percent, if I had the decimal of 0.43, so 0.43 to a percent, well, ladies and gentlemen, all you're doing is taking that decimal, when you're going back to a percent, move it to the right. So decimal to a percent, it's 2 to the right. Percent to a decimal is 2 to the left. So I guess if you were looking at me on the screen, it might be the opposite way. But needless to say, 43, when you're changing a decimal to a percent, that's 2 to the right. 2 to the right. 2 to the right. So if we move 2 to the right, 0.43 as a percent is 43%. 43%. So let's see what else from here we can do to kind of give a little bit of help. And I know, and I'm well aware that there is this part down at the bottom that does actually, that this bottom section right here does give a good information as well too. Sometimes you have to be kind of figuratively slapped in the face to kind of see these things as they are. But with that, so with that being said, so let's change a percent to a fraction. So percent to a fraction, let's say in the instance of 75%. What's the fraction form of 75%? Well, 75%, when you're talking percent, it's based out of 100. So it's based out of 100. A percent is based on 100%. 100%. So as a percent, it's 75 over 100. And the question then becomes, let's reduce that fraction. Well, can we reduce 75 and can we reduce 100? Sorry about that. Let me make sure my audio is still going here. Should be good. There we go. Okay. I got myself on a delay. I'm testing myself. I got myself on a delay here, making sure that we're good on a delay here. So making sure we're nice and good. So let's reduce 75 over 100 to its simplest form, because down here, it is everything that's reduced. So it's a reduced fraction. You don't see 75 over 100 down here. You don't see it. You have to reduce the fraction. So the question becomes is what goes into 75 and 100? I would hope for all of you who are dealing with money of any sort, think of 100 as a dollar. Think of it as a dollar, and what you have here, well, what makes up 75 cents? 75 cents is made up of 3 quarters. So think of your quarters, which are 25 cents. Think of your dollar is made up of 4 quarters. So if you go back and let's kind of refresh here, 75 over 100 can be reduced to 3 over 4. So 3 over 4. I think that covered all the parts of this specific page here. Fraction to a percent. So if you took fraction to a percent, I'll try to do this rather quickly and let you guys roll. So fraction to a percent, 3 over 4. So 3 over 4, this is where, at least in my instance, I grab our nice handy dandy calculator here. 3 over 4, I take 3 and I divide by 4, and look what you have. You have yourself a nice big old decimal, 0.75. And then what you do is, now that we remember from changing a decimal to a percent, we're going to be moving that decimal point 2 to the right, which makes the percent 75%. So fraction to decimal, decimal to percent. And can you move back and do it this way? Yeah, definitely can. And I think that's, yes, to the right, yes. So I think I covered all of that. Let's see here. I didn't get anything else. But definitely with this whole aspect here of changing like a fraction to a decimal. So fraction to a decimal, if you don't know the quick part off the top of your head, so like in the instance of what's the decimal form of 1/2? Well, it's half. Half is 50%. If you get a 50% on a test, that means you got half the questions right. So if out of the 10 questions that you had on the test and you got a 50%, that means you got half of your questions right. if you reduced 5 over 10 to a fraction, or to its lowest terms, that would be 1/2. So 1/2 to a decimal, well, 1 divided by 2 is 0.5. And then moving that decimal to a percent, you're going to move it 2 to the right. 2 to the right would make that 50%. Hope this helps. Hope this helps. I'm going to, in a minute here, I'm going to sign off of this feed and hit on to the next feed so I don't have a one whole hour and 30-minute-ish feed right there. So I'm going to take a look at the chat here. If there is anything, any questions with anything going on, let me get off of the screen real quick. Right to the right. And yes, good morning. Yes. Yes, it is a beautiful, beautiful Tuesday morning in Northeast Ohio, right? So let's see here. Mello, you still with me, man? You still with me? How you doing, dude? Thank you very much. So I'm gonna sign off with this feed, and then those of you who are I'm gonna try to separate it and then have the play ball packet will come on to the next one, just so that it's kind of separate, so we're not having to skim through a whole big thing. So ta-ta for now. I'll be back on in about 2 minutes.